Okay, on today's second instalment of the Robin Hood Archery DIY series, we're going to make one of these. And that is a DIY spine tester. Okay, before we go any further, I should explain something. This is not usually screwed to the side of my garden shed. It's usually in a nice, warm, cozy, dry office. But for the sake of the video, I thought I'd bring it out here so you guys can actually see it a little bit better. It's a fairly simple design. There are plenty of different designs online. If you Google DIY or homemade spine tester, or if you even on YouTube, if you search on YouTube for them, there's some really clever designs out there. I've opted for simple on the theory that with simple there's less things that can go wrong. Now, when I made this, I had no plans, I had no dimensions, nothing like that. It was made from scrap bits of wood and old arrow shafts, and a micrometer I had laying around. Yes, I'd got my inspiration from elsewhere online, as most people do these days, but let's have a look at this and I'll see if I can take you through how I screwed this together. You might not want to copy this one, you may do, but you might not want to. You may have better ideas. Great. I'm just putting the seed of the idea in your head so that you can take this and perhaps run with it. So let's see how I put this thing together. Okay, let's get to it. We're obviously going to need a few tools for this project, but nothing too major. Just something for measuring, a screwdriver, a bit of wood glue, a drill, a couple of drill bits, and that's pretty much it. Oh, and of course something for cutting the wood to your various lengths. So, the materials we're going to need. We're going to need, obviously, our backing board. Let me put it the right way up for you. Now, you can see on this one, I've already started marking it up so that you can see. This board is 20 by 73 centimeters, just because that's the piece of wood that I had. And I've measured a line up 8 centimeters from the bottom. And I've also put in a center line of the board. From that center line, I've marked out 13 inches one way, and I've marked out 13 inches the other way. That then gives me my 26 inches between my two. Hang on, let me see if I can get this in. I can't move the camera. Where are we? There we are. That gives me my full 26 inches between the posts I'm going to use for resting the arrow shaft on. Pretty simple. And at the 26 inch point, one on the left and one on the right, I'm going to drill holes to fit in an old arrow shaft. So that will be the next thing we need. So here are my two little pieces of 11/32 wooden arrow shaft. These particular ones have been cut to 7 centimeters, but you may have to adjust it for your project depending on the thickness of the board you've got. The thickness of this one I believe is about 18 millimeters, something like that, but it's not critical for the project. Now, to stop the arrow rolling around, you can see here I've actually filed in a slight groove, and the same on the other one. But unfortunately that wasn't enough to hold the arrow in place when the 2-pound weight was applied to it. So what I've done, I got these little O-rings, and what I do once it's all constructed is I just slip one O-ring either side of that groove, and that just holds the shaft in place whilst it's being measured. Okay, we need another couple of pieces for measuring the deflection of the shaft. We need a digital micrometer, and you can pick these up fairly cheaply these days. And what I've got here is just a piece of off-cut wood, a couple of screws, which is for mounting it onto the center point of the backing board. And here I've put a little strip of plastic so that when the micrometer is clamped onto it, it keeps it absolutely upright. Now obviously, to hold the micrometer onto our little lump of wood there, we need one of these cheap little sprung clamps which you can pick up just about anywhere. So that is the basic materials we need for the majority of the construction. What comes next is perhaps the trickiest part of the build. So the trickiest part of the build is going to be the 2-pound weight, which is directly applied to the arrow shaft to cause the deflection, and it has to be exactly 2 pounds. The two critical points for this build is the posts which hold either end of the arrow are set at exactly 26 inches apart, and the other one is the weight. The entirety of the weight must be exactly 2 pounds. Now the way I've constructed this one is I found a piece of metal pipe, I blocked one end with a washer, and then I melted lead weights into it until I got exactly the 2 pounds. Now you can see the end of this threaded bar here. That would be quite sharp and damaging to an arrow shaft. So what I've done, I've got a little rubber grommet, and that gets fitted onto the end there to save any damage to the wooden arrow shaft. And even this rubber grommet is taken into account when I'm measuring the weight. So when I say the entirety of the weight that forces or presses down onto the shaft must be 2 pounds, I do mean absolutely everything. Okay, so I'm stressing that because it is the most important part of the whole build, together with the 26-inch distance on your the pegs on the board. Okay, so that, my good people, is all the materials you need for the build. Let's just move out a little bit. Pretty simple. So let's go into the workshop and drill the holes we need. Okay, with the holes drilled, it's just a simple matter of fitting the pegs. So I'm going to apply a little bit of glue directly onto the peg and just knock it into place, making sure that it stays nice and straight, so the whole length is going to be 26 inch compared to the one on the other end. They're in. Give those a few minutes to dry and we can carry on. So with our end posts fitted, we can now turn our attention to the mounting for the micrometer. So we need a little length of wood that we made earlier. Now the measurements for this, it's 50 millimeters by 110 millimeters, and it's the same thickness as the backing board. And I'm going to mount this in the center position of the board so that the micrometer will be exactly in the middle, okay, and the top of the wood will be 3 centimeters below the center line of where the shaft will sit. Now that is to allow enough deflection of the arrow shaft to measure right down to some of the weakest shafts, right down to about 30 pound. So obviously that's going to be quite a bit of deflection on it. So let's screw that into place. So there we go. It's obviously very important that this is positioned at 90 degrees to where the arrow shaft is going to rest, so that when we clamp it in position we get nice consistent readings every time we use it. Okay, so far this is what we've got. We've got the backing board, we've got the two pegs, we've got the mounting block for the micrometer, we've got the rest at the side of the micrometer mounting block, and the micrometer and clamp itself. So it's time to move on to mounting the 2 pound weight. Two of the pieces that I forgot right at the beginning of the video with regards to materials are these eye bolts here. They're actually eye screws, and they all simply screwed in on the center line of the backing board, and you can adjust the height on these as well. So you screw them down far enough that when the actuating bar of the 2 pound weight actually meets the micrometer, which will be below the shaft. Once that's in position, you can then fit your protector foot on the bottom to protect the arrow, and your spine tester is almost ready to go, but for one thing. So at the moment we can mount the spine tester on the wall, we can put a shaft on, and we can zero the micrometer and actually get a deflection reading from it once we apply the 2 pound weight. But we don't actually know how that relates to the spine of the shaft. So we need these. Now these are AMO, if I can only say it properly, AMO Spine Charts, and I've actually done a metric conversion on here as well. Now these are available to download and print off and for you to use via the link below in the description. Okay, so click on there, it'll give you 2 PDF pages. Now I've laminated these so that they stay nice and fresh, as it were, and what I tend to do is I will mount one either side of where the micrometer sits, and then I've got an easy reference when I'm checking my shaft's spines, and I can just read off. So pretty easy build. We'll zoom back so you can have a look at what we've got here, and it's time to get it up on the wall. Okay, as you can see, it's a fairly simple build. Just to sum up, we've got our baseboard, we've drilled our holes at 26-inch centres between our 2 pieces of arrow shaft. We've mounted our 2 pound weight and the micrometer halfway between those 2 pegs, and we've printed off our AMO spine chart with the metric conversions, which I've put down here in the comments, in the links, so you can go to the Robin Hood Archery website and print those off. Feel free to use them for your own spine tester if you like. So although this is a DIY build video, let's just run how to use these things properly. Now whenever you're doing or checking the spine of a wooden arrow, you've got the grain to consider, and when you set the arrow shaft onto your spine tester, the grain should run vertically, up and down. Have a look at the picture, make sure it's always in that orientation, otherwise you're going to get a false reading. So let me check that I've got it in the right position. Okay, what I do next is I zero my micrometer to the bottom of the shaft. Now, as you can see at the moment, I've got to hold the weight up, which is a bit of a pain in the backside. So what I've done, out of a small piece of electrical conduit, I've actually cut a slot in there, and I can slip that onto there, and it'll just hold it up out of the way whilst I zero the micrometer. So once the micrometer is in position and now showing 0, I can now move it out of the way. Place the 2-pound weight onto the shaft, and you can see the deflection already, and then move the micrometer back up to the bottom of the shaft. Okay, so we can see on here that it's actually reading minus 11.77. Now, it is going to give you a minus reading doing the design this way. There's designs where the micrometer's on top, you'll get a plus reading. Doesn't matter whether it's plus or minus, it will still be the same rate of deflection. So 11.77, we now look that up on our spine chart. Let's have a look. So 11.77 is between 11.81 and 11.61, which means this particular spine is between 56 and 57 pounds, which is exactly what I was expecting, as I've just dragged it out of a set of 12 55 to 60 pound shafts. All right, so it's as easy as that. So with that one done, take the weight up out of the way, secure it, mark it up, job done. I hope you enjoyed this little video. It's a fairly simple build. I hope you get some use out of it. If you do and you like the video, please hit subscribe and like. It does make a difference. I like to hear your guys' feedback on what I'm doing, so I know things are going in the right direction. Okay, this is not a monetized channel in any way, but I do like to get your feedback, so please hit subscribe, hit the like button, and I'll catch you guys next time on Robin Hood Archery videos. Thanks for watching.